Okay, good evening to you all. Today the weather is so bad. So some of you said that there are power cuts and so on. So let's see what shall we do. But already there are 22 participants. So let's start today. So before going to the lesson, do you have any questions? Do you want to clarify anything? Some of you sent me the answers, very good, and I'm very happy about that. And they clarify the differences and all. So I invite others. So please do some exercises and clarify it with your friends. And also, if you want, you can send it to me and try to do it like that. Because this is not only like a theoretical subject, but there are some mathematical parts. So you have to clarify them. Okay, last day I gave you a revision on mathematical calculations. Then we were at the half of this session 9. So I want to remind you about that. And also we discuss some questions. No? Yes, today I hope to finish all the theory parts, and then next day is the last day of this measurement lecture. So at that day, I hope to discuss you about the model questions. And today also we have some questions. So on that day, we discuss about comparison and combination of scores. So yes, we discuss about why we want comparison and combination of scores. Because of the subject weightage, and if we compare all the subject marks together, that is not fair. Therefore, we have to go for some comparison methods. So to do that, we have to use standardized scores. So under standardized scores, I told you that we have to use a standard normal table. So we will do about the standard normal table today. And they are using this standard normal table, we have to use the normal distribution. But here for the calculations, we don't take normal distribution. There is a separate subject called educational statistics. Under that, you can study about those normal distribution curves and those inferential statistics and all. But here, we don't want to go for that. So just the introduction on that. That is for higher education. Beyond PGDE and BEd. So for PGDE and BEd level, this is enough. So then, based on standard normalized curve, we define Z score. Z score, I told you, that is not the Z score in A levels. This is the standardized score, is called Z score. It is the normal population. So there is the, this is the important one. This is the equation, Z equal X minus X bar divided by S. X is the score, then X bar is the mean mark, S is the standard deviation. So there we did this example also. There are 2 paper packets were distributed among 2 evaluators, and then we calculate their mean value of those evaluated papers and also the standard deviation. By looking at the raw marks, then we randomly selected 2 papers, and they are we saw that Sunimal gave 80 marks and Jaimal gave 70 marks for particular students. So then by looking at the raw marks 80 and 70, we can say that Sunimal's student is very clever than Jaimal's student. But when we calculate the Z value using this mean value and standard deviation, you saw that here the Z value is Z value for Sunimal's student is 0.57 and for Jaimal's 0.72. By looking at that, we can see that this student is more clever than this student. That is why we say that by looking, if we take decisions by looking at the raw marks, that may be wrong. Therefore, we have to go for standard scores. I told you that is why we give district ranks at the scholarships, scholarship examination and also A-level examination. That is why we go for such type of standardized things in order to get rid of the such unfair incidents. So if there are 2 scales, we have to convert them into common scale. So then we discuss about weightage average. That is, I told you that that is like your GPA, calculating your GPA, like credits. You have several credits for the subjects. So then when you get any mark for the subject, so it will be multiplied by the credits, number of credits of the subject. Then they will sum up. So that is weightage average. So GPA is the best example. And also Z score in A levels. That is another example for weighted average. So are there any questions? Then we discuss about translation of scores. There are again set scores were there. Then there are some problems of set scores. So one problem is decimal points. So what are the other problems? Can anyone say? Instead of decimal points, there are another 2 problems in Z scores. That is why we go for another other scales. Can anyone tell me? Who were there? Afra, you were there on that day. Can you tell me?
Negative values?
Yes, negative values. Very good. The other one, Risna. Yes. Dhananjana. Salma. Gayani. Yes, negative value, then decimal points. The other one? Zero value. Can be 0. Yes.
Yeah.
Assume that if the mean value is the rounded mark, it is like 69. If one person got 69 also, so the Z value will be 0. So with zero values, we can't define the average or anything of the student. So those are the problems in Z-score. Therefore, we have to go for another scales. That is why we use McCall scale. They are McCall suggested constants. So he said, take the mean value as 50 and take the standard value as 10. By using those values, according to him, we can have at least positive answers. Without zero, we can get rid of zero and we can get rid of negative marks. But there can be decimal points also here, but not such small decimal points. So based on Z value, so Z value is equation for Z value is x minus x bar divided by SD. So based on that, we substituted the McCall's values. So Z equal XM. XM is McCall's mark minus instead of x bar, that is mean value. So McCall's mean value is 50. Divide by McCall's standard deviation is 10. So then we have to subject XM from this equation. This is the equation. Now, Z equal XM minus 50 divided by 10. Using this equation, we have to subject XM. That is what I calculated here. Is it clear for you, this rearrangement? XM minus 50 over 10 equal Z. So division 10, we have to take the division 10 into the other side. So if we take division 10 into the other side, we have to multiply it. So that is why Z by 10 here. Here now XM minus 50 equal Z by 10. Here we want to get rid of this minus 50 here. So we have to add 50 into the other part. That is why XM equal Z into 10 plus 50. So McCall's mark is also called T-score. Therefore, we can use T-score here, T mark also here. T equal Z into 10 plus 50. Is it clear?
Yes, ma'am.
Then, to use this T mark or McCall's mark, we have to know the Z value of the particular mark. Therefore, first we have to find the Z value. Then already we found two Z values for those two students. No? So then that day we substitute those values here. XM equals 0.57 for Suranga's 80 marks into 10 plus 50. Here you got 55.7. And then again from Eranga, that is 57.2. So those results, by looking at those results also, we can say that Eranga is clever than Suranga. I think this is where we stopped on that day. So this is McCall's scale, McCall's score or T-score. So there is another mathematician called Hull, C.L. Hull. He introduced another score similar to McCall's score. There he gave another constant. That's only. He also suggested the mean value as 50 and standard deviation as not 10 but 14. That is the difference. Like we got the equation for XM, here also XH, Hull value. So XH, according to the Z score, we can substitute it like this. XH Hull mark minus 50 divided by 14 equal Z here. Then we have to subject XH here like that. So then you can obtain XH equal Z into 14 plus 50. That is Hull's scale. Nothing but here only 14 mark is the difference. In McCall scale, that is Z by 10. Here Z by 14. So same thing can be calculated here. We already know the Z value of those two students. So then we can find the value Hull's values for those scores. So let's do it. Tell me the Z score of Suranga is 0.57. So then we have to multiply 0.57 into 14 plus 50. Tell me the value 0.57 into 15. Just calculate and tell me. Shafiq sir, do you have any answer?
I am trying.
Okay.
57.98.
7.98. Final answer is 57.98.
Yes, thank you, miss. Yes, the answer is correct. 0.57 into 14 is 7.98. Final answer is 57.98. Please do the other one also. 0.72 into 14 plus 50.
10.08
Yes,
plus 50.
yes. 10.08 plus
60.0.
50. Yes,
Yes,
very
so it
good.
was
Thank you, miss.
60.
60.08. That is Hulk mark. Hulk score. So then, this is another most important score, that is percentile rank or PR, percentile rank. Percentile rank, to get the percentile rank, we have to use the frequency distribution table. Can you remember the frequency distribution table? We discussed last day also.
Yes, madam.
Yes. Frequency column is there. Then if there are class intervals, then we have to use X mark, middle mark, then frequency table, then fx, cumulative frequency, and we calculate the percentage frequency, then percentage cumulative frequency. We want that column for percentage rank. So please wait, there may be some students who were absent on that day, therefore so in the next session, today's next session, I'm going to discuss about that also. So it's better to remind it here. So I told you I didn't discuss about histogram, frequency polygon, frequency distribution, curves, because you did it in your presentations. But for the completeness of the course, today I hope to discuss them with you. Histogram, frequency polygon, shapes of frequency polygons and schooners, then percentile cumulative frequency curve or cumulative frequency curves or ogives. So let's discuss about this part, interpretation of graphs, then move on to the previous one. That's better, I think. Histograms. Here you can remind the cumulative frequency, cumulative percentile frequency. So this is the class interval. Then here I told you that to draw the histogram, you have to have the real limits. By looking at the class intervals here, 35 to 39. Then there is again 40 to 44. So there is a gap between 39 and 40. That's why we have to go for real limits. So to obtain the real limits, we have to subtract 0.5 from the lower mark, and we have to add 0.5 for the upper value. Then we can have continuous real limits. So then frequency is here. Cumulative frequency is addition of the frequencies one by one from the lowest value. Value means lowest class. So here the lowest class frequency is 3. So then 3 by 6, 9. 9 by 5, 14. 14 by 8, 22. Like that. That is called cumulative frequency. So if you interpret it here, 28 means there are 28 students or 28 candidates who got 59 or below 59 marks. 59 or below 59 marks, there are 28 students. That is how you interpret the cumulative frequency. It tells us the below number of candidates for the particular line. So then cumulative percentile frequency. First we have to calculate the percentage of these frequencies. Then we have to take the cumulative percentile frequency. Is this column clear for you? How to calculate percentile frequency? We have to calculate, first we have to calculate percentile frequency. Then only we can have cumulative percentile frequency here. That column is not here. Is it clear? Or if you want, I can do it again. To calculate percentile, here the frequency is 3, no? So the total number of students are 50. 3 divided by 50 into 100. Divided by 50 into 100 is 6. So here 6, again 6 divided by 50 into 100. That is 12. Like that, we have to calculate the percentile frequency. Then we have to consider the cumulative percentile frequency. Is it okay?
Yes, madam, we are clear.
Okay. So then, based on real limits, we have to go for histogram. Histogram is we have to draw the bar charts, bar graphs. Here, continuous bar graphs. So the x-axis is taken as real limits and the frequency is y-axis. Here the maximum frequency is 8, therefore it's enough to go for 10. So here the lowest limit is 34.5, highest limit is 84.5. So no need to go from 0, therefore that is why another cut here. Then it starts from 30 and ends from 90. So the first real limit 34.5 to 39.5. So frequency is 3. That is why this bar here. Likewise, we have to draw the relevant bars here. This is called histogram. Based on this histogram, I think this is all easy. Based on this histogram, we have to define frequency polygon. You know polygon. Polygon is the closed shape, closed figure. That is so the least number of so the polygon with least number of sides is triangle, then rectangle, squares, then pentagon, hexagon, like that. Polygon is the closed figure which has more than 3 sides. So using this histogram, we have to create the frequency polygon. This is the frequency. So based on these frequencies, we have to draw the polygon. To do that, we have to consider the midpoint of this polygon histogram bars, like this. Consider the midpoint of each and every bar and take a ruler and combine them. Then we want to, polygon is the closed figure, no? Therefore, we have to close this. In order to close this, we have to consider the extra half value from this x-axis, from the lower side, and also from the upper side. Here the lowest limit is 34.5. Here 34.5. Then we have to consider another. The class range is 5. No, another 5 here, and take the midpoint of that. And then connect the first point and this point. Then with the x-axis, we can have the polygon, closed figure. Without the histogram, the polygon is like this. If you calculate, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides in this polygon. This is called frequency polygon. Is it clear? By looking at this frequency polygon also, we can get many data. So the highest frequency is like this, like that. There are several purposes for using histograms, frequency polygons. And another one is frequency distribution curve. Here the shapes of frequency polygons and skewness. Shapes of frequency polygon. Now you know, you can see the here the frequency polygon is here. So there is a standard frequency polygon shape that is like a bell shape. Beyond that bell shape, we can have several types of frequency polygons. But the basic polygon is considered as bell shape. Then based on that, we define the skewness. Skewness is the degree of asymmetry observed in the probability distribution. When data points on the bell curve are not distributed symmetrically to left or right sides, the median The bell curve is skewed. Distributions can be positive or positive and right skewed or negative and left skewed. This is the example stock market prices and the distribution of average individual incomes comes under this. This is the symmetric frequency polygon. If the more values are distributed to the right side, so then we can have the tail for the left side. It means there are only few numbers in the left side and more numbers are skewed to right side. This is called skewed left. This tail is left side in the left side. This is called skewed left. Here the tail is right side. It's called the skew is right. Skew is the tail here. Here, according to the skewed left, so the mean, median, and mode, those central tendency measures are coming to the higher side. It means right side in the skewed left. In the skewed right, those values tend to come to the left side. So in the symmetric curve, symmetric frequency polygon, the mode, mean, median, all central tendency measurements are equal here. This is the sample. Actually, this is the sample. Based on this symmetric sample, we define other shapes. Here, the negative skew indicates that the tail is on the left side, which extend towards more negative values. Positive skew indicates the tail is on right side, which extends towards more positive values. A value of 0 indicates that there is no skewness in the distribution, meaning distribution is perfectly symmetric. Here, percentile frequency distribution curve or cumulative frequency curve. Another name is ogive. That is a curve that represents the cumulative frequency distribution of group data on a graph is called cumulative frequency curve. Representing cumulative frequency data on graph is the most efficient way to understand the data and derive results. There are two ways to draw this percentile cumulative frequency curve. We will discuss all these things. In the graph, first put the lower limit on x-axis. Then mark cumulative frequency on y-axis. Plot points x, y using lower limits versus their corresponding cumulative frequency. Then join the points by a smooth freehand curve. These are the steps like this. Later you have the example, then you can understand. There are two types of cumulative frequency curves or gives. More than type cumulative frequency curve and less than type cumulative frequency. That is, here we consider the lower limit. No, there are two types. We can draw the ogive using lower limits and also using upper limits of that class. That is why we have two types. That is called more than type and less than type. It is like this. More than type. In more than type, we have to consider lower limit. Lower limits of the classes and the frequency. It is like upside down S, but upside down S. Its shape. Then less than type, here, there we have to consider upper limit. Then it is elongated S. The shape is. Both are on the same graph, and this point is indicates the median. Here is how to draw the OGIV, or cumulative percentile frequency, not percentile, cumulative frequency curve. Here the marks means class intervals are here, number of students. It means frequencies here. Here they consider upper boundary. Upper boundary means less than this type of, less than type cumulative frequency curve. By considering the upper boundary, here the upper value is 10. So upper boundary is 10.5. Upper value is 20 here. So upper boundary is 20.5. 30, 30.5. Like that, 100. Yes, 90, 90.5. It cannot be 100.5. So that is 100. So x-axis should be 0 to 100 here. So then cumulative frequency this is how the 21.5 the limits taken. So the cumulative frequency, so the lowest one is lowest class frequency is 1, then 1 by 2, 3, 3 by 4, 7, 7 by 7, 14, 14 plus 5, 19, 19 plus 8, 27. Like that, cumulative frequency is considered there. Here the upper bound value is 10.5. So its frequency is 1. Here 1, 10.5. The point is here. So then 20.5, 3. Second value 20.5, 3. Third value 30.5, 7. It's 7 here. Likewise, you have to mark the data points, and then using freehand, you have to connect these dots. It is like elongated S. Based on this cumulative frequency curve, we can obtain some data. Here, the example for calculating the quartile. So the total number of students here are 32. So 32 plus 1 divided by 4. 33 divided by 4. Answer is 8.25. So then cumulative frequency, you have to select 8.25 value from cumulative frequency. It means y-axis. Then mark the horizontal line until you meet the curve, and then mark the vertical line until it cuts the x-axis. So that value is 33. So that is why Q1 value is 33. Percentage is from 100. No, that is why 33%. Likewise, you can calculate this is Q1, then Q2, Q3. And if you want to find the mark for the frequency 20, so then also you can obtain such data also from this. This is cumulative frequency curve. So when we consider, this is our, wait. We can come to this slide later. This is how to obtain data from cumulative frequency curve. Here, percentile rank. Percentile rank. So we stop from percentile rank. Before that, I want to give you the knowledge on histograms, frequency, polygon, and frequency curve overview. Then, percentile rank. Percentile rank is a common statistical measurement that you can use for everything from comparing standardized test scores. Statisticians often use percentile rank to get an idea of how particular assessment score or results compares with others in a set. Additionally, understanding percentile rank can give you an insight into how well you are performing on any given assessment. Means by looking at the percentile rank, you can understand that there are this number of students who got below this mark. Like that, you can analyze your results. Percentile rank is a common metric statisticians calculate when scoring standardized tests and examinations. This measurement shows the percentage of scores within a norm group that is lower than score you are measuring. This is the example. Here. This is the marks. Then frequency is here, cumulative frequency here, percentage cumulative frequency is here. So the highlighted row in the highlight here, the mark 20 is highlighted here. By looking at its percentage cumulative frequency, that is 32. It means, as I told you earlier, there are 32 students who got below 20 or 20 marks. 20 marks or below 20 marks. 32% students, not 32 students, but 32% students got 20 or below 20 marks. That is the meaning of that. So PR, percentile rank 20. Percentile rank 20 equal 32. Understood? By just looking at the table, you can take the answer. It's PR 27 means, here, PR 27 means equal 90. Like that, by looking at this, you can obtain the value. It's easy. Let's see what happened in the class intervals. Here, class intervals are. So, class intervals, frequency, cumulative frequency, and percentile cumulative frequency. So, you are asked to find the percentile rank for the score 58. Now, the question arises. Where is the score 58? Here we have to assume. Assume means we by looking at the class intervals, we can see that 58 score should be in this class interval within 55 and 59. 58 score should be there. So we have to select this row. 58 score should be in this class interval within 55 and 59. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we have to select this row. 58 score should be there. So we and then draw the percentage cumulative frequency curve. This is one method. There are two methods to calculate this percentile rank in the class intervals. First one is using percentile cumulative frequency curve. Second one is using the equation like we did last day. Like we did, we use equations to find the median, mean, standard deviation. Like that, we can use formulas also. Here, like cumulative frequency curve, similarly, we can draw percentage cumulative frequency by considering the upper limits of the class intervals into x-axis and the percentage cumulative frequency to the y-axis. Here not cumulative frequency but percentage cumulative frequency. Then we have to mark the data. It means 34.5.
Oi, Nama.
3.75. Like that. First, we have to mark the data points. And then in freehand, you can connect the code. Like this. Then,
Nama.
please mute your mic, Gayani. So you have to draw this graph in the graph papers. Then it's easy to obtain data. You are asked to find the percentile rank of 58. Here, using this table, we identified 58 should be here. No? Therefore, using the x-axis, we have to find the 58 mark in the x-axis and then draw the vertical line upwards until you meet the curve. Then draw the horizontal line to the y-axis. Then obtain that value, that is 37.75. So PR 58 equal 37.75. In the other way, if you are asked to find the find what is the PR, what is the point you can have PR value as 50. Then you have to go backward from cumulative percentage cumulative frequency 50 and then downward, that is 63.6 is here. Likewise, using this curve also you can obtain the answer. But you know, always it's not possible to draw graphs and obtain results. Therefore, we can use the equation like this, PRX. I told you, when you see these notations anywhere, I is what? I always here, width of the class. N is total number of data points. F is the frequency, particular frequency. Then capital F, cumulative frequency of the lower class to the included X. Cumulative frequency of the lower class, which we consider the class. Then X is the data and L is the lower limit of the considered range, considered interval, lower real limit. So in this course, those are the all notations we use. Where it is, you have to apply it. Here PRX, if it is for find the median, so that is that equation. So the notations are same. Now let's see how to calculate it. So again, the same table here. So 58 is here. Now we identified what are the class interval where 58 is. Then n is 80. Number of cumulative frequency 80, no? Maximum values of n, capital N equals 80. You are asked to find 58. So x equal 58. F is the cumulative frequency of the class which is lower to the considered class. So considered class is 55 to 59. So the lower class is this one. So its cumulative frequency is 26. So L is the real lower limit of the considered class, that is 54.5. I is 5 and F is 7. The thing is, you have to substitute these values here. 100 over 80, that becomes 1.25, 1.25. Then 26 plus 58 minus 54.5. That is 3.5 divided by 3.5 into 7 divided by 5. Likewise, we can have the answer as 38.63. So from the curve, we obtain that value as 37.75. From the equation, we obtain that is as 38.63. So what will be the most accurate? Both are accurate, but there may be some slight differences, because when we draw the curves, there may be some approximations because of the squares in the graph paper. Therefore, there may be some slight differences of the answers. That's okay. If you are asked the questions, there is a answer range. Therefore, it should be included there. So if you can use either way, both methods. Method 1 or method 2, that's okay. So we are okay for both values. Because of practical problems, there may be slight differences. Yes, now we can discuss these questions. Now we finish that session. So we didn't do this one because we okay. Let's do all. Explain the necessity of converting raw marks of norm reference assessment with examples. I told you to refer what are the norm reference assessments again, and yes, I gave you, I told you to refer those things. Can anyone tell me what is, first to write the answer for that, you have to remind what is a norm reference assessment. So this is our first session. What is the norm reference assessment? Who refer that? Nilupuli, can you? If you can give me the example, that's fine. Mayumi? Or Risna? Gayani?
It can be a comment whose score is referred to as the norm.
Can you tell it again? Can't.
And it compares
I can't hear you. Can you repeat it?
It compares students' performance with the performance of a large group of similar students whose score is referred to as the norm.
Yes, very good. Here it compares the student with the large group. Example. It's correct.
IQ test.
Yes, IQ test. So normal example in 8A or 8B, in 8A class, the highest mathematics score will be maybe 91. So 8B may be 89. So according to 8B class, so that student is first in mathematics. But if he is in 8A class, he is not first in mathematics. So likewise, norm reference means according to the norm, there we compare the student's performance with the large number of group. Very good. So then explain the necessity of converting raw marks of norm reference assessment with examples. Yes, norm is rank. That's also correct. We rank the students like the first in the class, second in the class, third in the class. Class-wise, we rank the students. That is norm reference assessment. Explain the necessity of converting raw marks of norm reference assessment with examples. Why is it necessary to convert these raw marks?
Because to check their real performance or the
Yes, very
standard
good.
of the student.
Yes. In order to check their real performances, we have to convert them into standard scores. Otherwise, as I told you, with examples means, I told you in civics, the subjects like civics, there are only 2 periods per week. But the main subjects, there are 5 or 6 periods per week. So then, if we compare all those marks, one student, assume that one student took 90 marks for civics and 60 marks for maths. So we can't say that he is not clever for, he is not a good performer for maths. We can't say like that. That depends on the type of the paper. Therefore, we have to consider, if we compare maths mark, we have to consider the whole maths marks of the class, not with other subjects. Therefore, in order to find the real performances of the students, we have to convert those raw marks into the standard marks, standard scores to get the fair decision. So then, second one, define percentile rank. Percentile rank. What is that?
It allows for comparing students to their peer group.
Yes,
It's
very
not an
good.
indication of how many questions your child answered. It
Yes.
indicates the how well child did relative to other students who have also taken the test when comparing
very good.
students.
We can compare the students. Like we can say that there are 32% of the students who took below 20 marks. Like that, we can take as teachers, we can compare them. We can take the ideas of that. We can take the remedies. So percentile rank is a common metric statistician calculate when scoring standardized test. It shows the percentage of scores within a norm group. That is not explain it clearly. Very good. That is percentile rank. State the strengths and weaknesses of percentile rank as the conversion score of norm reference assessment. Strengths. What are the strengths? Advantages or strengths of percentile rank, PR. See, easily we can interpret by looking at the thing is we have to calculate the percentile cumulative frequency. Then by looking at it, we can interpret the ideas. That is the main strength. So then, as Visna said, it helps us to conceptualize data. And actually, we can summarize our data, summarize the scores of the students by looking at that very clearly. So what are the disadvantages? Disadvantage is it doesn't give us internal information. There in the class intervals also, within this interval there are some differences. So there are variations of marks, but we can't obtain those behaviors of marks using percentile rank. It gives only the surface value. Those are the weaknesses of percentile rank. So then calculate the percentile ranks for the given each and every mark. Now you are given marks and frequency here. What to do now? Can we do it by keeping the table like this? No.
No.
We have to change this table into vertical side. So first column should be marks, then frequency, then so try to do it by yourselves. I'll give you about 5 minutes. So you have to find the percentage mark also, then percentile cumulative frequency. Then I will do it. Try to do it. Please all try. When I gave you the sum, 20 were there, now 15. Don't give up. Sometimes that may be because of heavy rain. So can't blame. Is this time enough? Still trying or time is enough? How many marks are there? Total number of marks? Yes, 40. Okay, let's do. So tell me, can you see the board? Can you see my board?
No, ma'am.
No? It's shining up because of light. Still can't?
I can see, madam.
You can't see. Others?
Can see, ma'am.
Can see.
What about that? So here its brightness is here because of light. So others can see, no? Okay, that's all. What can I do? Okay, here marks are here, then frequency is here. Then we have to take the cumulative frequency. From where we have to add? From here or here? Upside from 20 marks or from 30 marks?
From 30 marks.
No. Here the data are in the ascending order, not descending order. Therefore, we have to consider the first as here. In the examples, we did in descending order. Here it is ascending order. In the examples we discussed, see, this is descending order. So we started from the lowest class. Understood? So likewise, you can have Different types of questions.
Excuse me, ma'am.
Yes.
Ma'am, is it okay to write down according to the descending order, the
Yes.
graph?
Yes, okay.
Okay, ma'am. Thank
That's
you.
why when you do something, do it with the understanding. That's all. There is no the standard method. So if you take the cumulative frequency, if you start it from here, that's wrong. You have to start from the lowest value. That's what I want to emphasize. So here cumulative frequency 2, then now you can do it 5. This one, how to find percentage frequency. One by one, you have to calculate. So who told me that she can't see the board? What about her? Can you
No,
see?
ma'am. It's yeah, can visible.
Okay. So then how to find this?
We have to divide the frequency by 40 and multiply it by 100.
Yes. So I write here, can't see. Yes. 2 divided by 40 into 100. So that becomes 5. You can see that. 12.5. So then 9. So easy to 45 by 2, 20. Then 14. 14 into 5 by 2, no? 35. Oh no, I'm wrong. But why? I'm wrong here.
Because we must take the summation of the cumulative frequency for the
Sorry.
denominator.
Yes. So here, I want to consider not 5, 3 here. 3 divided by 40 into 100. 7.5. Don't take this. We have to consider frequency only. Then 4 divided by 40 into 100. Again. Okay. 5 here. 12.5. Is it correct? Correct, no?
Yes, madam.
Yes, correct. Then 10.
It's 25.
25. Again 5, 12.5. Again 4, 10. Again 2, 5, 5. 5. 1 means 5 over 2, 2.5. Then percentage cumulative frequency. Again, we have to start from here. 5, 12.5, 22.5,
35.
35, no?
Yeah, 35, ma'am.
60, 72.5.
72.5, 82.5,
Hmm.
87.5, 92.5, 95.
And 100. Yes. Now we have to write, calculate the percentile ranks for the given each and every mark. So you can write, can you see? PR 20 equal 5. That's all. Then PR 21 equal 12.5. So the thing is, you have to calculate this column. You have to find this column. That's it. Then you can write the answers. Is it clear? Yes, I know, Afra, because of bad weather, most of you can't hear and can't connect. So try to be with the recording. I think that it's clear for you. Are there any questions?
In a percentage of cumulative frequency, can you show me one calculation?
No. No calculation, just adding. 5 here, then 5 plus 7.5, 12.5.
Okay.
Like we did in cumulative frequency from frequency.
Adding the percentage.
Yes, adding the
Ah.
percentage.
Okay, thank you.
Likewise, are there any questions? Okay, so then third question. Mathematics marks of 40 students are given below. There are class intervals and frequency. Calculate its cumulative frequency and percentage cumulative frequency. Calculate the percentile ranks of marks 52, 37 and 66. Here calculate means there is a class, there are class intervals. Therefore, we have to go for the equation or the curve. Here let's do it with the equation. So let's do it. Try to do it. Asks you to calculate cumulative frequency and percentage cumulative frequency. So here, where should I start to find the cumulative frequency?
From 30.
Yes, from here. 1, 4, 8. Then percentage frequency. Again 40. 2 over 40 into 100. Means 5. Is this side okay? Are there any? Am I correct here?
Yes, madam.
Okay. Then percentage cumulative frequency. Start from here. We have to start from lowest class interval. So then 2.5. 2.5 plus 7.5, 10. 10 plus 10, 20. 20 plus 15, 35. 35 plus 20, 55. 55 plus 30, 17.5.
72.5.
72.5. Then 82.5. 95 and 100 here. So then calculate its cumulative frequency and percentage cumulative frequency. That's okay. Now we have to calculate the percentile ranks of marks 52, 37 and 66. First take 52. Where is 52? So here you have to mark that row. 52 should be here. No? Then go to the equation. Here the equation. Can't see. Can you see? Yes. PRX equal. Can't see red color, no? Can you see red color?
Can.
F plus X minus L over I into F.
We can't see, ma'am, because of the light.
Yes. So then what to do? Can't see here also. No?
Down we can.
Now can. Low. No, 66.
We can there.
Ah. So the equation is PRX equal 100 over N F plus x minus L over I into F. So N is 80. So 100 divided by, sorry, N is 40. Can see. Capital F is the cumulative frequency of the class which is below the selected class. This is the selected class. So the below class is this one. That's cumulative frequency is 14 plus x is the value is 52 there, minus L is the lowest class limit here. Our class interval is 50 to 54. So lowest class limit is 49.5. Divide by I, width of the class, 50 minus 54 minus 54, 4 plus 1, 5. Into its frequency, 8. Now, simplify. 2, 5, so PRX. Here x means 52, PR 52 equal 5 over 2, 14 plus 52 minus 49.5. 2.5. That's simplified. 2.5 over 5 is 0.5. 0.5 can see, no? 14 plus 0.5 into 8, 4. So it's easy now. 5 over 2 into 18. 9 and 45. Value is 45. Clear? Is it clear?
Yes, ma'am.
So you can do 37 and 66 by yourself, no? 36 is here, then 66 is there. So likewise, you can do it. No need to do it now, no? What are your ideas? No need to do 32 and 66 here, no? What do you think? Can do the others? 37 and 66?
Yes, we can do, ma'am.
Yes. Then last day we discussed this, but we didn't calculate. What is Z-score? What are the features of it? How do you calculate it? We discuss it. Then calculate the following according to the given data. Convert all raw marks into Z-score. Then take the addition of marks of each student. Then calculate the relevant Z-score. Let's do it. Hurry up and find the Z-scores of all marks. So the Z-score equal X minus X bar divided by S, standard deviation. So orderly calculated. He said, I wrote, he said Rani science 60 minus 50 over 10. So calculate it 10 over 10, it becomes 1. Similar, it's here 1. Here 15 over 10. 1.5. That is for science. Then for maths. He said Rani for maths. He said Kamani for maths. Then he said Susima for maths. He said Rani for Sinhala. He said Kamani for Sinhala. He said Here, convert all raw marks into Z scores. Is it okay? Did you get the answers? Are there any differences with my one?
It's okay, madam.
Yes.
Same answer.
Rafiq says cannot hear. Others can hear? Can hear me?
Yes, madam.
So it means there is problem with Shafiq. Signal problem, I think. Then take the addition of marks of each student, then calculate the relevant Z score and take the addition of it, then compare and identify the clever student with reasons. Find the space. So then we have to add the row marks first. Total row marks. 60, 60, 50. 170. 65, 45 and 57.
167.
Yes, 167. Those are the row marks. Then let's calculate the Z scores. So I put it in red color. 1, 1.5. Here 2, 1, 0.5.
0.5 minus 3 minus 3 minus 1.6.
Yes. Then let's add all. So that is total Z value. 0,
0 minus 1.4.
0.4. Now you can see, according to the row values, who is the clever student?
Susima.
Row values? Here 167. Here
170.
Shravani.
Yes, then Rani. Rani is the clever student according to the row marks. But according to the Z marks,
That is
Susima
Susima.
is the, yes, Susima is the clever student. Take the addition of it, then compare and identify the clever student with reasons. What will be the reasons? When comparing with row marks, here we consider the total all subjects as same. But when we consider the Z marks, here we separately consider the mean values and standard deviation values for separate subjects. There we consider their places according to the subjects. Subject performances. So finding the Z value is the best way. Understood?
Yes, madam.
Madam, can you say it again?
Sorry.
Can you repeat, madam? I could.
According to the row marks, when we consider addition of row marks, there we don't consider the subject values. Subject value is, give me 1 minute. Okay, very sorry. When we consider the row marks, here we don't consider the subject difficulty or subject relevancy, anything. We just add up those row values and justify that the clever student is Rani. But when finding the Z score values, Z values, here we found the Z values of particular subjects regarding the mean value and standard deviation value of that particular subject. Not at all. So this Z mark means that is regarding the all performances only for science paper. This is performances for maths. Performances on Sinhala. So, according to the Z score, the value clever student is Susima. So, the fair method is finding the Z score because there we consider the subject values. Means subject weightage, not weightage, but we compare the students according to the subject. Subject performances, not at all. That's what I wanted to say. Is it clear?
Yes, ma'am. Thank you.
Yes, then the last question. What are the features of T-score or McCall's score? Features means they are, he introduced a T-score in order to get rid of what?
Negative values and decimal points and zero values.
Very good. Negative values and zero values. So how do you convert the row marks into T-score? There you have to write the equation. T equal Z into 10 plus.
10 plus 50.
Yes, very good. Plus 50. Convert all row marks in question number 5 into T-scores. Now we found Z scores. Then one by one we have to convert them into T-scores. That's all. There are no need to compare. Just convert them. For one T-score for Rani science, that is Z into 1 into 10. That value is 60. Like that, you can have all 9 values. So if I do minus part here, T Rani Sinhala minus 3 into 10 plus 50. Minus 3 into 10 minus 30
Minus
plus
30.
yes. Answer is 20. So now you can do it, no? Is it clear? Is it clear for you all?
Yes, madam.
So then now the time is 9:30. So no time to do the latter part of session 10. Let's continue the latter part of session 10 into next day, and then we'll do the questions like this. Model papers.
Okay, madam.
Okay, then no time to discuss that. Okay, then thank you all and good night.
Thank you, madam. Good night.
Thank you, ma'am.
Thank
Good
you,
night.
madam. Good night.
Thank you, madam. Good night.